Bismillahirrahmanirrahim. Today in this video, I'll guide you how to create an amplifier circuit in your Proteus. So it's quite easiest way to design your amplifier a Proteus circuit. So first have a look at, you will go on the component mode. In the component mode, you will click on P. When you will click on P, first you draw a transistor here, 2N3019. Okay, you will double click here and your transistor will come. Now I will provide the biasing to this transistor. How I can provide the biasing? I will place a few resistors here. How I can place a resistor? Now I will select a resistor here. Yes. No. Double click here and I will draw multiple resistors in a different way. Third thing, I will draw power supplies. I will click on the DC voltage source here and I will click here and then here. Now I can complete this circuit very easily. I will click on this reset button and I will select this transistor here from here. Yes, I will place here. Now I will bring this resistor on this position, sorry, on this position. I will connect this resistor with resistor transistor, right, and now I will place power supply on the input. Power supply, got it. Then I will place a resistor on the emitter. I will rotate this resistor clockwise. Yes, and now I will connect this resistor. Now I will connect this resistor with the emitter of the transistor, and now I will click here and connect these two ports. Now once again I will connect power supply, means VCC, on the output, and how I can do this procedure. And I will place somehow it should be here. Connect this resistor with power supply and then this resistor with the amplifier. Negative side I will connect from this resistor, and now I need earth or ground. Now I will connect this ground here. That's right. So this is your simple circuit. Now I can change the parameters. How I can change the parameters? Parameters means 12 volt. I can apply voltage instead of 12 volt, 20 volt. Right, I will click on OK, and then resistor. I just connect the resistor of 100 ohm on emit base, and then I can connect a resistor of 100 ohm on emitter, and now I can connect a resistor of 100 ohm on collector. I also can change this voltage from 12 volt to 20 volt, and then I will click on OK. So this is your whole configuration, you can see here. And now I will delete this extra resistor from here. Yes, delete it. And this is your I can change the parameter R1. Okay, then R2. I will set this one to be R2. Yes, okay, and then I will double click on R, and I will click on R3, and that's it. So now I will have play the circuits, and there is no error is being showing on this circuit. There is no error showing in the circuit. Now I will stop this running up. Now I will stop to run, and then I will go to this position, and I will connect DC emitter here, and I want to check the IB current. And how I can check IB current here also, and I can also check the IC current here. So what will be the procedure? I will delete this leg and I will delete this leg. So I will connect positive with this terminal and negative with this terminal, and now I will connect positive with this terminal, and then this terminal, and negative with this terminal. Now I can calculate IC from here, and at the end I can check the DC voltmeter against DC here. And how I can check? I will connect this one here and this one here. I will also want to place a switch here button, BUTTO, and I will write here, and push button, single push button I will place here. Now I have rotated it, and then I will click on the outside, and then I will connect positive here and negative here. Right. Now I will change the parameter of the resistor. I will change the parameter of the resistor. How I can change? From ampere to microampere, okay, and from ampere to microampere, right? And now here I can change it volt, millivolt. Definitely, maybe somehow volt will appear here. So this enough now, and then I will run again. Now you can see the maximum current is being passing from here. IB is the maximum, and IC is also showing maximum. And now in this stage, 2.06 volt are dropping across VC, collector to emitter voltage. When I connect this push button, I press, and now you can see that this is a short, and now no voltage are being dropping here. Now I will convert the scale from microampere to milliampere. What I will do? Milliampere here, okay, and then milliampere here, then I'll press OK, and then I will run this circuit again, and now you can see here IB current is being showing 44.3 milliampere. It is IB. IC current is 67.5 milliampere flowing in IC, and now this time voltage are being dropping 2.06 volt across DC. Now I want to increase the input voltage from 20 volt to 25 volt. What will be the response of this circuit? Now I will into 25, and how much voltage will drop? Now I will check. Run, and then you can say that when voltage on base are increasing, your VCE voltage are decreasing. Before this, voltage were higher, but now the voltage are decreasing. Now I want to increase the voltage on VCC 20 volt to 25 volt. I will click 25, okay, and then I will run again. Then I will run again. Now you can see that when VCC voltage are increasing, your VCE voltage are increasing, and this time current is also increasing here on the IC. So this is the overall behavior of the circuit, and you can check your IC and IB in your amplifier circuit very easily. So this was the whole tutorial about your Proteus, your circuit, and you can check easily your IB, IC and VC voltage by increasing the input voltage VBB and VCC voltage, and you can check the behavior of this. Now in the next class, definitely I will move on how the amplifier work as a switching device. So stay tuned with my tutorials. Please like my video, subscribe my channel, and hit the bell icon. Definitely, you will get more videos that will enhance your practical knowledge, especially about electronics and electrical circuits. Thank you very much for watching.